Okay, so what can we do with this? Well, the hypotenuse is still a radius of the unit circle, so the hypotenuse is definitely 1 unit long. Okay, but again, it can't be a right triangle if there's a 120-degree angle, because 120 degrees plus a 90-degree right angle, that's already 210 degrees, and a triangle can only have 180 degrees. Okay, so what do we do? Well, remember this angle from here to here was 120 degrees. So the rest of it to the x-axis, the negative x-axis, right? This is 180 degrees. Okay, so 180 degrees total. You've gone 120 degrees. So you have 60 degrees remaining. Okay, so even though this line represents 120 degrees to the positive x-axis, it's also 60 degrees away from the negative x-axis. Okay, so we can go ahead and label this angle in here as 60 degrees. Okay, so now we have the special right triangle that we saw before. Okay, so using those same side length relationships, we could calculate the, we could do the x, 2x, radical 3x stuff again. Or we can notice that this 120-degree triangle is a reflection of the 60-degree triangle. All right, so that's why I told you to use the same color. Okay, so we do need to be careful about one key thing, though. Okay, so first, the vertical side. So this side. So this side reflects over here, and it's exactly the same, right? It's radical 3 over 2 units upward. Okay, but here's where things get different. The bottom side of the triangle, which we said is half a unit long, that also needs to reflect over here, right? But let's think about how the coordinate plane works, right? You've got positive numbers over here, you've got positive numbers over here, but to the left are negative numbers. Okay, so even though this side was positive a half for the 60-degree triangle, when we reflect it over, now that it's going to the left, we need to call it the negative version. Okay, so it seems kind of funny for a side length, but we need to consider this to be not half a unit wide, but negative 1/2. Okay, so now on the other paper, the chart, the table. So even though the triangle has the 60-degree angle, the row we're going to use is the 120-degree angle that we started with. Okay, so we're going to do sine, cosine, and tangent for 120 degrees. So sine, as always, is opposite over hypotenuse. So positive radical 3 over 2 over 1. So anything divided by 1 stays the same. Next, cosine of this angle. Cosine of the 120 degrees. Cosine is adjacent over hypotenuse. So negative a half over 1. Again, anything divided by 1 stays the same. That's very convenient about the unit circle, right? That when you divide by the hypotenuse, dividing by 1 keeps it the same. Okay, and then lastly, tangent of the 120-degree angle. Tangent is opposite over adjacent. So radical 3 over 2 over negative a half. Okay, this one's not as convenient, so maybe I'll do the math off to the side. Radical 3 over 2 divided by negative a half. I can rewrite as radical 3 over 2 times negative 2 over 1. So 2 divided by 2 is 1 whole. So negative radical 3. Okay, so now we know, okay, sine of 120 degrees is radical 3 over 2, cosine of 120 degrees is -1, tangent of 120 degrees is negative radical 3. Yeah. Oh, yeah, sorry, I miswrote that. Thank you. Okay, yeah, sorry, I wrote the wrong number for cosine. It should have been -1/2 divided by 1 is still -1/2. Okay, so let's move on to the next angle, 135 degrees. Okay, and again, if you were color coding, maybe you can figure out which color you should use here. It's going to be the 45-degree color, because again, let me just draw this off to the side. We're calculating 135 degrees, but since the triangle is going to be formed over here, we need to figure out how many degrees are remaining. So 180 minus 135 means the triangle will have a 45-degree angle. Okay, so from the positive x-axis, again, 135 would be around here. Oh, sorry, let me go back and if you remember, we were labeling the coordinates of each of these points. So let me go back and do that for the 120-degree angle. Okay, the 120-degree angle, the point where it hits the unit circle, the x-coordinate is -1/2, and the y-coordinate is positive radical 3 over 2. Okay, so back to the 135-degree angle. Again, we want to form a right triangle, so we draw the line straight down. It's called an altitude. That forms a right angle with the negative side of the x-axis. Okay, and I already showed over here that the missing piece, so the triangle angle will be 45 degrees. Okay, so the hypotenuse is again a radius of the circle, so it's 1 unit long. Okay, but rather than again calculating everything, let's just use a reflection. Okay, so the 45-degree triangle over in the top right reflects over here. Okay, so again, the 1 matches to the 1, that works. The height of radical 2 over 2, it's still radical 2 over 2, right? Both of these sides are positive, they're both going upward. Okay, but the bottom side, it used to be going right, so it was positive, but now when you reflect it, it's going to the left, which is negative. Okay, so just like the previous triangle, we have to consider this a negative x value. Okay, so we consider this negative radical 2 over 2. Okay, so let's now do sine, cosine, and tangent. Sine opposite over hypotenuse. So positive radical 2 over 2 over 1. Anything divided by 1 stays the same. Cosine adjacent over hypotenuse. Okay, so adjacent over hypotenuse. So here we've got negative radical 2 over 2 over 1. Okay, and then tangent, opposite over adjacent, opposite over adjacent. So positive radical 2 over 2 divided by negative radical 2 over 2. Okay, I'll do that off to the side. Again, to divide fractions, we can instead multiply by the reciprocal. Okay, so these cancel out, but these also cancel out. So it equals -1. Okay, so let's go ahead and do the coordinate for that point. So where that 135-degree angle hit the unit circle, that point, the x coordinate is to the left, so it's negative radical 2/2. And the y coordinate's going upward, so it's positive radical 2/2. Okay, so questions about anything so far? All right, so let's have everyone try the 150-degree part. Okay, so again, you're gonna draw it on your circle using, I'm sure you can figure out what color to use, and then use that to fill in that row of the chart as well. Okay, so go ahead and take a few minutes to try that, please. All right, so the 150-degree angle, right, where would that go? 150 degrees is over here. So we stop a little bit short of 180 again. So how much is remaining? 180 minus 50, you have 30 degrees to go. Okay, so that one will go about here. And you can form a triangle again by bringing the altitude down. Okay, hypotenuse is still 1. This is 30 degrees. Okay, so you can reflect the height directly over. But the width, when you reflect it, it goes from positive to negative. Okay, so sine opposite over hypotenuse, positive 1/2 over 1 is still 1/2. Cosine adjacent over hypotenuse, negative radical 3/2 over 1 is still negative radical 3/2. And then tangent opposite over adjacent, opposite over adjacent. So 1/2 over negative radical 3/2. So okay, so here I'm going to rationalize it. The radical 3 in the denominator, you can do times radical 3 over radical 3 to get negative radical 3/3. All right, so next up is 180 degrees. But if you do 180 degrees, you're already on the x-axis. So if you draw the line straight down, you don't go anywhere. So you again cannot form a triangle with the 180 degrees. Okay, so again, we'll just skip it for now. So, oops, too far. Okay, so we'll skip 180. That brings us to 210. Okay, so where does 210 take us? Well, 210 is more than 180, right? So 210 is a little bit past the 180. Okay, so we want to know how far past, right? So 210 minus 180, you went 30 degrees past the negative x-axis. Okay, so I'm going to use the same color then that I did for the 30-degree angle. Okay, so 210 degrees will be about here. And again, what that actually represents is from here to here is 210 degrees, right? But the part that we're more interested in is the remaining part. So from here to here was 30 extra degrees. Okay, so we still want to form a right triangle. Obviously, we can't go straight down anymore. So this time you go straight up. Okay, so if you go straight up, you do indeed form a right angle. Okay, so now the triangle that we're working with is over here. Okay, we already know that this is 30 degrees. We already know that hypotenuse is a radius, so it's 1. Okay, and you can again use reflection. You don't need to calculate by hand. I probably wouldn't use this triangle anymore. I would use this triangle, right? You would just reflect it down. Okay, so actually this side is already overlapping, right? These two triangles have the same middle side. So the negative radical 3/2 is still true. Okay, now what about the vertical one? Well, it was positive a half because you were going upward, but when you reflect it, now it's going downward. Okay, so we consider this to be negative 1/2. Okay, so the three measurements for this triangle are negative radical 3/2, negative a half, and positive 1. The radius is always positive. It can never be negative. Okay, so the hypotenuse is also always positive. Okay, let's do the sine, cosine, and tangent of this. Sine is opposite over hypotenuse, negative a half over 1 is negative a half. Cosine is adjacent over hypotenuse, so negative radical 3/2 over 1. And tangent is opposite over adjacent. Okay, so opposite over adjacent, negative a half over negative radical 3/2. Okay, seems like an awfully familiar calculation, right? We basically just did it, except the signs are different. Okay, so negative times negative becomes positive. So again, 1 over radical 3, we can rationalize to radical 3/3. But this time it's positive. Okay, so we should be able to do the rest of the circle pretty quickly now, right? Just by using reflections, we don't really need to do too much calculation at this point. We just get to reuse stuff we already have. Okay, so go and take a few minutes, please, and see if you can fill in the rest of the unit circle. So let me just make sure we did this correctly. 90 degrees is the point 0, 1. You go 0 left to right, but you go 1 full unit up. Okay, so remember the y coordinate is sine because it's up. Okay, so y is positive 1. Cosine is x, which is 0. And now tangent, so let's just write it here. So sine is y, cosine is x. Tangent is y divided by x. Okay, so 1 divided by 0, you can't divide by 0. So we say that this tangent of 90 degrees is undefined. Okay, so that's the word that I would like you to use. Yes, sir?
Why is it not like 0?
Because, for example, 8 divided by 4 one way to understand this is you have 8 objects and you want to see how many like bags do you need if each one can fit 4 objects. Okay, so it takes 2 bags to account for all 8 objects, right? So that's why the answer is 2. Okay, but if you try like 8 divided by 0, right? You've got 8 objects, but each bag fits 0. So you're never actually like using up the objects, right? So you're never going to get an answer. So yeah, it doesn't really make any sense to divide by 0. Okay, let's finish up the rest. 180 degrees, that's directly to the left. So since it's in the negative x direction, the point is negative 1, 0. So sine the y coordinate is 0. Cosine the x coordinate is negative 1. And then tangent y over x. So you can have 0 in the numerator, just not in the denominator. Okay, so 0, negative 1, 0. 270 degrees. That angle hits the unit circle at the point 0, negative 1. You don't go left or right, but you go 1 unit down. Okay, so sine will be negative 1. Cosine will be 0. And then tangent, negative 1 over 0. Again, dividing by 0 is undefined. Okay, and lastly, 360 degrees. So if you go all the way around, you're back to where you started. So just like 0 degrees, 360 degrees is the point 1, 0. So sine the y is 0, cosine the x is 1, tangent would be y over x, 0 over 1 is 0. Okay, so we now have our sine, cosine, tangent fully filled out. So yeah, I didn't do the radians part. We'll do that later. But one moment. Okay. So questions on any part of the chart? Okay, so there's a couple other things we need to understand. Okay, so next, we stopped at 360 degrees, but angles can go beyond 360 degrees. So how would we handle those? Well, let's just think about it, right? So again, here is where we start. So if you go 360 degrees, you're back to where you started. So if you go another 30 degrees, right? So if you go 360 plus another 30 to this angle, that'd be 390. But you land in the same place as the 30 degrees. So even though you got there in different ways, you land on this point with this x and y coordinate. Okay, so it's just going to repeat over and over. Okay, so the angles from 360 to 720 are the same as from 0 to 360, basically. Okay, so we'll say that it repeats the pattern of 0 degrees to 360 degrees. Okay, so the way that you would actually calculate the value is you would find the coterminal angle between 0 degrees and 360 degrees. Okay, so that means that if I were to say, ask you, what is the sine of, how about 450 degrees? All right, so this is not on our chart, but what I'm telling you you can do is first find the coterminal angle between 0 and 360 degrees. Okay, so if you remember coterminal angles, you add or subtract a full circle. So in this case, we would subtract a full circle. So 450 degrees and 90 degrees are coterminal. Okay, so sketch-wise, 450 degrees would look like this. It would do one full loop and then an extra 90 degrees. While 90 degrees would only be from here to here. So the sketch is different, but they both end up in the same place. Okay, so that means that sine of 450 degrees is equal to the sine of 90 degrees. Okay, again, even though the sketch is different, they end up on the same point on the circle. Okay, and then sine of 90 degrees, the y coordinate, right, is +1. Okay, so the answer to the second question is basically the same. We've also learned about negative angles, right? So before 0 degrees means negative. Okay, so same idea. Let's say that I asked you for the cosine of negative 120 degrees. Okay, so what you could do is find the angle that's between 0 and 360 degrees. So this time, since we're starting negative, you would add a full circle instead of subtracting. Okay, so again, sketch-wise, negative 120 degrees would be like this, while positive 240 degrees would look like this. Okay, so they're not the same angle, but they're coterminal, which means they end up in the same place. Okay, so that means that cosine of negative 120 degrees is the same thing as the cosine of positive 240 degrees. Okay, so again, what's the cosine of 240 degrees? -1/2. Okay, so the strategy is the same, right? Find the coterminal angle. Between 0 degrees and 360 degrees. Oops. Okay, so now questions 3, 4, and 5. I'm asking about in which quadrant is each of the trig functions positive or negative. Okay, so go and take a moment to look back at your diagram is probably better. And list for me, okay, in which quadrant or quadrants is the sign a positive number? On the other hand, in which quadrant or quadrants is it a negative number? And then repeat for cosine and tangent. So sine, where is sine positive? So actually, maybe it's better to look here. So sine is positive for these and for these. Okay, so 30, 45, 60 all have positive sign, and so do 120, 135, 150. Okay, so at quadrants 1 and 2, sine is positive. On the other hand, sine is negative in quadrant 3 and quadrant 4. Okay, so hopefully you have the chance to think about the reason that that makes sense. We'll explore it more next class. Okay, where is cosine positive? So I'm just gonna write the answer. Cosine's positive in 1 and 4, and it's negative in 2 and 3. And tangent's positive in 1 and 3, and it's negative in 2 and 4. Okay, so with that in mind, we're going to sort of do a problem a little bit in reverse now. Okay, so I'm telling you that this point is on the unit circle. So negative 1/2 means to the left of the origin. Positive radical 3/2 means up. Okay, so that's the point. So first I asked, what's the quadrant? Well, again, so you start with quadrant 1. It's not there. It's in quadrant 2. Sine, we don't need to bother drawing in the triangle, right? We know sine is the y coordinate where it hits the unit circle. So sine is the y value. Cosine, again, cosine is the x value of the point. Tangent is y over x, so that one we might need to calculate. Okay. For this next one, this one's not a quadrant, it's on an axis. Okay, so go ahead and take a minute and see if you can answer these two. Okay, you should be able to do these without looking back at your drawing or at the chart. So try to do these two without looking it up, right? Just use the patterns you've learned. Okay, so 0, 1 would be directly downward. Okay, so it's on the y-axis. If you said negative y-axis, that's great, even more specific. Sine, the y-coordinate, -1. Cosine, the x-coordinate, 0. Tangent, y over x, so that's undefined. Okay, and then over here, negative x coordinate, negative y coordinate, so that's going to be over here. So that's quadrant 1, 2, 3. Sine the y value, negative radical 2/2. Cosine the x value, also negative radical 2/2. And tangent y divided by x. You're dividing it by itself, and negative divided by negative is positive. All right. So the last thing is finding the trig ratios for other angles. Okay, so like for this first one, cosine of 7 pi over 4. Right now, I'm sure you guys are more comfortable with degrees. So you probably would convert this to degrees first. Okay, so remember, is it pi over 180 degrees or 180 degrees over pi? Well, you want the pi to cancel out. So you would put the pi diagonal. That leaves the 180 up here. So pi's cancel out. 180 divided by 4 is 45. So you got 7 times 45 degrees is 315 degrees. Okay, so what happens every year is students do this part and then they forget the rest of the problem, right? Like they convert the angle to degrees, but they forget to actually do the trig function of it. Okay, so you can turn the radians to degrees first, sure, but then you still got to do, in this case, the cosine part. Okay, so for this one, I would encourage you to, use your unit circle to answer this. Okay, so yes, we have the chart, but it's a lot faster to do the circle than the chart. So like I'll just tell you, a good test strategy would be to draw the unit circle on a blank paper. And then you can answer all these questions very quickly. Okay, so if you have the circle filled out, cosine of 315 degrees, 315 degrees is right here. Cosine is the x coordinate, right? So radical 2 over 2. Okay, on the other hand, what about sine of negative 30 degrees? So this one's already in degrees, but we don't have negative 30 marked on our unit circle. So you could find the coterminal angle of it. Again, you're allowed to add or subtract a full circle. So sine of negative 30 degrees will be equal to the sine of positive 330 degrees. And again, now you can go to your circle. You're going to 330 degrees, and sine, you want the y coordinate. Okay, so 330 degrees, the y coordinate is negative 1/2. Okay, so that's the idea. So go ahead and take a moment and try some of the rest of these. Again, you're welcome to use your unit circle to help, but you got to figure out what angle to look at first.